This project is on privacy-preserving auction with multi-party computation, also known as MPC. I am Benny, and the project is supervised by my supervisor, Dr. Suraf. The project can be broken down into two main parts: a privacy-preserving auction and MPC. Starting with MPC, it is the idea of having several distinct yet connected distributed parties to carry out joint computation securely. Examples of computation include finding the sum of all inputs, or the highest value amongst all input from distinct parties. So the key to MPC is its focus on being secure. We define an MPC to be secure by ensuring it upholds 5 main security principles. The first being privacy, where the distinct parties can perform the computation without leaking unintended information to other parties. Secondly, we have correctness. Depending on the computation itself, the result of the computation has to be correct and not influenced by any particular party. Independence of inputs is how malicious parties cannot have inputs based on the inputs of the honest parties. Guaranteed output delivery is how honest parties should be able to receive the intended output despite the presence of malicious party. Lastly, in the presence of malicious parties, if they are to receive the output, honest parties must receive the same output as well. Moving on to the next part of the project, it is the development of an auction. Specifically, we are developing and testing a double auction. So a double auction is where there are both buyers and sellers that will submit bids based on their purpose. We then have the auction to be periodic. This means that the auction will accumulate bids and only perform computation at a fixed timing. And all of that is with the volume maximizing goal for the auction. So for any given clearing price generated by the computation, it will be a price that maximizes volume transaction for both sellers and buyers. So this is the overall architecture of the application developed. We have bidders that will submit their bids into intermediaries that are either sellers or buyers. These bids will be accumulated and processed by the intermediaries as needed. The auction organizers will then be the party that will initiate the periodic computation amongst all intermediaries. This computation is done through an MPC protocol, and the output will be delivered to all intermediaries once completed. The architecture is designed in a way to ensure the application is robust, redeployable, and simple to use for MPC developers to test their algorithm. For each of the intermediary, we have the front end, where the bidders are able to interact with, and the back end that is connected through RESTful API with the front end. The back end will store and process the bids in the database and communicate via MPC with the auction organizer when needed. The decoupling of the front end and the back end allows developers to easily integrate their stack of choice when needed. When needed, it can also be scaled separately to ensure better resource utilization. To ensure the infrastructure is consistent and redeployable, we utilize Docker, Docker Hub, and Docker Compose. This allows future developers to simply pull a pre-built image from an online repository and compile their algorithm as needed with the necessary libraries. Docker Compose also allows us to better manage the varying number of auction players when necessary. Our front end and back end is built with Flask and React.js respectively, and we also use the state-of-the-art MPC framework from Data61 known as MPSpades. With our application developed, we tested our application and algorithm with experiments. The two main goals is to ensure correctness and to measure performance. In order to test for correctness, we have multiple datasets with pre-calculated clearing price. Only after we ensure that our algorithm and application is performing correctly, then we move on to test for its performance. Performance for MPC application can be measured in two major ways, namely the time taken and the data transmitted. So we perform multiple experiments with random datasets and varied parameters to the MPC in order to measure its experimental performance. After our experiments, we arrive with two main insights. Firstly, developers need to be wary of the exponential growth in both time taken and data transmitted when the input or intermediaries increase. Unfortunately, this remains one of the main drawbacks for MPC despite the improvement from recent developments in the field. However, we managed to notice how the size of the bid itself do not show any relationship with time taken and data transmitted. This helped us arrive in the insight where multiple bids with the same price can be collated at the intermediary's end to reduce the total number of bids. By having block prices instead of continuous prices might also be one strategy applications can utilize to reduce the total number of unique bids. This definitely helped in the performance of MPC application. We now move on to the demonstration of our application. So this is the screen of the front end for our auction organizer, where we can initiate our multi-party computation when needed and when it is ready. So when we look into our Docker Compose file, so this Docker Compose file is where we set up our different configurations needed for our experiments. So what you can see over here is we pull our image over from Docker Hub. So in that case, we don't have to manually compile through many different times whenever needed. And we also have different environment variables where you can see on the right side with our environment file, we're able to set certain parameters. So now we look into our Docker file, and in our Docker file, you can see how we abstract all that complexity of installing different libraries needed. And we also can compile certain files, and we can also solve problems when it comes to line endings with Windows. So we can now look into how we can simply run the entire application with a single command, docker compose up. So once this command is run, all the different parties will be provisioned immediately. So we have buyer 1, buyer 2, seller 1, seller 2, the auction organizer, as well as the front end for the auction. So if we look into the Docker itself, we can look into the different logging which is available for us. So looking into our auction organizer, we can see that it's already running. So what we can do is we can look into our front end for the auction organizer. So we see that it is compiled successfully. So over here, what we can do is once we click on initiate, the MPC process will begin and the computation will start. So we look at how in our logs we can see that this computation is already begun. So the different logging can be done in order to help the developer check whether the MPC process is successful or not. So for the interest of time, we'll skip to when the MPC process is completed. So over here we can see that the MPC process is done, and we log certain information including time, data sent, and also we have the results displayed over in our front end. So we can see for this particular experiment, we have a clearing price of $88, and then we will have different banks. So we output the information on which bank buying or selling how many different units given the current clearing price. So this project continues to have a lot of potential, and one of the ways is to migrate and test our application on the cloud. By developing on Docker, the migration to the cloud should be a simple feat, and considering how most applications are hosted on the cloud, the performance of MPC on the cloud would better provide a good reflection on the experimental performance of the application. We can also push the project further by developing a graphic user interface for experimental configuration instead of having to work on the backend code when the parameters of the MPC needs to be changed. So this will help extract the complexity of development away from MPC developers.